All right, so the previous video showed you how to use the handheld drop sensor. Now, if you want the best results, what you do is you order a magnet lid. And you can take off this handheld lid and replace it with the magnet lid. And this is what will give you the most accurate results. So use this electromagnet to attach it to a steel plate that's stationary, and then you get extremely precise drop measurements. So I'm going to show you some of the data from the video. I made a separate video of doing a bunch of drop tests using this drop sensor, and now I'm going to show you the data from that. Okay, so this is a drop test using a magnet at 82 inches, and the fall height is exactly measured at 82 inches. The fall height calculation is accurate to plus or minus 1 inch when you drop it with a magnet from a stationary platform. Okay, so that's where you get the best results. This had a head injury criteria of 551, 107 Gs, and that correlates to the peak. Okay, so it was safe to fall 102 inches, or I'm sorry, 82 inches onto this playground surface. And it's considered safe unless the head injury criteria goes above 1,000 or the max G goes above 200. If either of those conditions are met, this graph would be red instead of green, and the light on the drop sensor would be red after the test. Okay, so that's a magnet drop. Now let's look at the corresponding hand drop. This is the hand drop done at the exact same height, but what I did is I disengaged the magnet and I held it by the fingertips before I let go. Instead of letting the magnet do its job, I did it by hand. Now it's going to be less accurate. In this case, it was pretty good. It measured to within 1 inch of the actual drop height. And even though the inches are a little bit off, the max G force and the head injury criteria are accurate. That shows exactly how hard it hit and how dangerous of a landing that was. Now the thing is, because when you drop it by hand, it takes a little longer to start free fall. It doesn't quite land as hard as it would as if it were dropped from a magnet. So to be conservative, if you're doing hand drops, you should probably go an inch or two above the required height so that your data is a little more conservative, just to be safe. But let's look at some more drops. Okay, so this is a magnet drop, 82 inches. In this case, it measured 81 inches. Like I say, it's accurate to plus or minus 1 inch. But these are accurate to 0.5%. So these are very accurate. This is less accurate, but it's good enough. All right, so now I'm going to go back. This is a hand drop at 82 inches, and it measured 84. So it's 2 inches off, okay? Because of human error. There's a lot of different ways that the human can introduce error into the data. And I'm going to show you a little bit more of that. Okay, so here's another magnet drop at 80 inches. It measured 81. That's within specification. Magnet drop at 80. This one measured exactly 80. That's good. Hand drop at 80. This one went 84, so it's 4 inches off. And so I'm going to show you why that is too. And this is a magnet drop at 80. It measured 81. Hand drop at 80, and it measured 83. I think there's one more drop on here. Magnet drop 80, and it measures exactly 80 inches. Now I'm going to show you how I showed you how we do the calculations for that, but let me show you the diagnostics in the Z axis where we calculate the fall height. Okay, so this is these are just the low G Z in the Z direction. Now see, this one was a hand drop of 82 and it measured 85. And the reason why is because I was holding it by hand and I was trying to hold it steady. I didn't do this on purpose, but humans, we're not perfect. We're not robots. And so there was a little bit of, it wasn't exactly at 1G because I wasn't holding it as steady as possible. And so that's why this fall height is, in this case, 3 inches off from the actual height. Okay, now let me show you some better results. This is a hand drop at 82. It measured 81 inches. This time I was able to hold it more steady, pretty close to 1G. And then it's, as I let go of my fingers, it begins to fall. The detector, the sensor says, okay, I see that we are now in free fall, and it calculates the time, and then based on the time, it calculates 81 inches. All right, now here's a magnet drop. Notice the difference here. See, the nice thing about the magnet is there's a much more instantaneous transition from 1G down to 0G. And so that's why the fall height measurement is more accurate when you drop it from the magnet. You see, there's a sudden transition as compared to the hand transition. No matter, that's letting go as quick as possible. But the reality is you can't let go instantaneously like a magnet. And that's where your error is introduced. It has to decide, okay, does free fall begin here? Does it begin here? And then because when you first let go of your fingers, it's going to slide a little bit. It's not going to land quite as hard as it was if it's dropped from a magnet. So this is, 501 Gs at 82 inches, not 501, 501 Hick. Okay, so this max G has to do with that doesn't apply to the G force. That has to do with this curve here. But anyway, so 501 versus 550, and that's because when it releases suddenly, it hits a little bit harder than when you release by hand. Okay, so that's why that number is higher. The max G just says it goes from from basically a total delta of 2 Gs, but that includes these artificial markings. Okay, so now here's another hand drop. Again, you've got this smoother transition between 1G and 0Gs. But the magnet drop, oh, that's another hand drop. You see, this one took a little longer to decide, okay, we're in free fall. Another hand drop. There's a magnet drop. Okay, so if you want the best results, you use the magnet lid. I think that's pretty clear. Okay, there's another hand drop, and so forth. Magnet drop. Okay, so I think that makes sense. All right, hopefully that's answered any of your questions. If feel free to email me if you have any more questions. My email address is A as in Anthony, E as in Edward, and Bent as in Bentley. So aebent@q.com. I'm happy to answer any questions that you might have. All right, thank you for watching.